Software architecture, design patterns and principles, and all-around IT put into one podcast.
The goal is simple, to give you even more from DevMentors.
My name is Peter.
My name is Derek.
And let's discuss the software as we know it. Welcome to the third episode of Software as You Know It podcast. In today's episode, we've got a great guest, Jakub Nabrdalik, who is an expert in the area of microservices. Jakub has worked with really huge and complex distributed systems containing hundreds or even thousands of microservices, and they were all quite successful. In today's episode, we'll talk about things like Microservices Fundamentals, how the Conway's law affects the organization, what are the common challenges and what are the common mistakes when it comes to building the microservices, how to deal with all this culture, how to make the appropriate culture around the microservices, and how to transition from monolithic application to the microservices application. This and many more topics are being discussed within this episode. Hello, Jakub. It's great to have you here with us. So please introduce yourself.
All right. So my name is Jakub Nabrdalik, and I've been developing commercial systems for the last 19 years, mostly as a software architect. So I was responsible usually for the whole thing, but sometimes as a manager or in other roles as well. I got some experience with systems from 200 people on a single monolithic system to 700 people on microservices, on 700 microservices, and everything in between, including the small projects as well. These days, what I do is I work within teams to help my clients basically move from monolithic systems on-premise usually to the microservices in the cloud. And I work there as a consultant. Basically, I help design those things. I do audits for those things. And also I develop as a single developer just within a team, right? So I have kind of a hands-on experience, I would say, with all that. I also give workshops and talks on architecture, distributed and modular architectures. And also, I teach a little bit of everything, basically Spring, reactive programming, test-driven development, behavior-driven development, domain-driven design, all these things.
Yeah, I would say honestly that when we think about the distributed systems in general and microservices, I would say that at least in Poland, you're one of the most recognized, I would say, experts in this topic.
Thank you.
Yeah.
And of course, there are other topics that I immediately would pin to yourself, but yeah, the distributed systems are I would say this primal topic, and it's of course not the coincidence that we chose the microservices for our first discussion together, because today the main topic is of course about the microservices, and of course I would say that we're recording this in 2022. I mean, we all know the microservices as a developers. It became a buzzword quite rapidly, I would say. And now there's dozens of materials on the YouTube, some other platforms, of course, books, blog posts, podcasts about the microservices. But I would say that there's still a lot of confusion, especially on the more advanced topics, which are not that obvious. And hopefully we'll today tackle a few of them, especially basing on your experience on your daily basis. But let's just start from the fundamentals. And if you just could explain, let's say to the junior developer who's kind of confused about this topic, what are the microservices, and what's the difference between maybe microservices and their regular applications being, let's say, monoliths?
All right. So I would use the definition by Sam Newman in his book Building Microservices. He's one of the first people who actually worked on microservices when the ThoughtWorks actually coined that term. So he worked there. And so he says, microservices is a distributed system. So a bunch of applications that are talking with each other. But the main thing is that all those applications are deployed independently. So basically, you need to have independent deployments to have microservices. If you have to synchronize the deployment, then what you have is something called distributed monolith, which has got no benefits of microservices and all the problems of distributed systems and of a monolithic application. So it makes absolutely no sense to do that.
Okay, so it's good that you mentioned this independent deployment because it might sound easy, but I guess this is, let's say, one of the key principles and also one of the key challenges when it comes to building this the proper microservices solution. So I guess that based on your experience as software architect or as consultant, and also a little bit on our experience when we did some workshops, what do you think would be the circumstances or the goals that must guide this particular company in order for microservices to bring some measurable benefit? Because it sounds like this architecture requires or actually adds more cognitive load, which might directly impact the, let's say, overall cost of the project, the resources that are needed to run these services, and so on.
And I would add personally one thing to this question, because typically if you would type, let's say, on the YouTube, you have the microservices, let's say, startup or something. There's, as I mentioned, there's lots of different materials on the microservices, and what I found out was that once you start describing the microservices as based on the definition like you gave to us, presented to us, the very, I would say, key advantage of microservices besides the deployment itself is scalability, and this is, I would say, some sort of the main advantage that people try to use to explain why would you actually use microservices, because at first glance it makes no sense to have, let's say, 100 of applications instead of just one big monolith, because it's probably more hard to maintain. But yeah, this I would say scalability, horizontal scalability, is this keyword that is used to explain why we would like to have it.
Yeah, but it's actually wrong. The thing is, everybody talks about that, but it's not important. That's not the goal, and that's not the main benefit, okay? Now, the reason why it's wrong, from the technical perspective, it's okay. Yeah, you can scale different microservices independently from each other, which means that it's easier to do than in a monolithic application. But you could also take a monolithic application, turn on feature flags, and basically turn off all the modules instead of the one that you want to scale. And you can deploy that 1,000 times to different machines, and you got the same situation. And in terms of the JVM, for example, the only cost actually is the memory footprint, and that's it. And that's cheap, right? So the benefit of being able to scale different microservices, yeah, sure. Do you need that scale? To be honest, most of the deployments, most of the microservices I've seen are deployed in 2 instances, 2 of them, right? And that's only because you have 2 data centers, for example, right? And you want to have the failover there. And that's it. Quite often I see microservices like you only have 1 instance of that, and you're not going to scale it ever because of the business involved. So I would say that, yeah, sure, this is a benefit, but it's not important one. There are other important benefits, much more important than this, than being able to scale each module or each microservice independently. So first of all, you have to understand that there is a trade-off there, right? You have other options instead of going into microservices. And even within microservices, you have many other options as well in terms of the kind of an architecture you get. So first of all, let's say that, let's compare this to a modular monolithic application, because we are not going to talk about non-modular monolithic application, also called as a big ball of mud. This is the kind of anti-pattern everybody knows, and there's a lot of applications looking like that. But these are bad examples, right? We are not going to talk about bad examples because why would we?
Yeah, exactly.
So So compared to a modular monolithic application, a well-written modular monolithic application, what are the trade-offs and what are the benefits and what do you need to have to be able to benefit from microservices? First of all, every single monolithic application that you're going to have will have a big problem with deployment risk, right? Imagine this, you have 100 people working on a single code base, right? If there is a memory leak done by a junior developer 3 teams away from you, right? Your application and your modules and your basically your code is going to crash. For example, on the JVM, that's a bye-bye situation. The JVM is going to close and you cannot protect against this, right? So a memory leak kills the whole thing. That means that whenever you're deploying a monolithic application, you are risking every single part of that system, right? And also because there are 100 people working on that situation, when it's a big project, right? Then what you have is you are deploying a lot of different changes, and you are not aware. Not a single person is aware of all those changes. Even if you hire, like let's say, the deployment manager who looks at all those changes, they are not aware of the code about the code. They haven't looked at the code, right? So all the monolithic applications have got the problem of big risk deployments. And the more people you have, the bigger the risk, right? With microservices, that's no longer true. In microservices, because you have independent deployments, you do not impact anything else, or at least if you get the architecture right. So that's one example, but the best and there's a lot of different reasons and small changes, like the things that you will get from microservices. But there's one large one. So there was this book, Mythical Man Month by Frederick Brooks. I think this was from like 70s or 80s. So that's quite old. And Frederick basically explained that you cannot have 1,000 people working on a single application. It doesn't scale. It makes no sense. There is a problem due to the Conway's law, and there are other problems as well, and it's just pointless. There is the size of a team, or basically the number of teams or number of people on a single code base, where when you are developing this as a monolithic application, you will slow down basically because of the communications, because of the errors, because we have to have some kind of a consistency there. So we will have to talk about with each other and so on. With microservices, that's no longer true. So the main benefit of microservices is actually solving the communication problems between teams. Okay. And it sounds like, okay, but we are going to complicate the technical part of the solution, so we can solve the culture part of the solution, or basically we can get the people not having to communicate with each other, right? The thing is that communication part hasn't been solved by anyone yet. Okay, so the technical part, we know how to do it. It's difficult, sure, but it pays off. When you have 100 people, it will going to be much faster developing microservices, even including all that technical problems and complexity and the cognitive load, instead of developing this as a single monolithic application. And you can just count that or read the Frederick Brooks Mythical Man Month book to understand why. So that this is the main thing, right? So the goal here is to get onto production fast and be able to write new stuff fast, and basically fast deployment, fast development. That's it, right? And at some scale, you will not be able to do it as fast with monolithic application. That's it. Now, the number of the developers, where that scale actually tips off to the microservices, right? That's a good question, and it depends on the level of the developers, and it depends on the infrastructure that you have, on what company provides, because if the company is already there with microservices, it's going to be easy. You're going to have the whole platform working for you. But if you are the first one, then you got to have to solve all the technical problems there, or take a public cloud, but it also comes with its technical problems there. So basically, it's a trade-off that you have to calculate. Basically, you have to calculate this. Now, with that comes another thing, which is that in order to benefit from microservices, the company has got to change. So there's a lot of different things. Let me focus on the main ones. First of all, you will have to go into the DevOps culture. DevOps meaning developers operating their own systems on production. Now, that's a huge change for companies like banks, for example, where it used to be that there was an operation department and there was the development department, and the developers do not have access to production, right? So now you have to change all of that because the operations will not be able to handle 100 microservices, and developers will gladly create those. That's one thing. The other thing is that operating your own systems in production requires certain level of knowledge. You will have to learn. If you're using Kubernetes, you will have to learn kubectl. If you deploy on bare machines, you will have to have good knowledge of the Linux machines or Bash or whatever else. So it also requires a different skill set, basically, right? So it's much more complex. There is a cognitive load on the team, right? Now, that's one thing. The other thing is it will require productization. So basically, you will have to stop thinking in terms of projects. Oh, my team is doing those microservices. That's part of a project. Instead, you will have to think in terms of products. That's a big change, and companies are quite often not ready for this, right? A product is something you can sell. And so you have a product owner, and that person can actually make decisions about the product, including situations when that person can say, okay, we are not going to implement that feature. It's okay for you, but it's not okay for us. And it's all right in microservices, but that's a completely different mindset to monolithic systems within the company. Then you have another thing, which is called the single point of truth, which you are going to have to follow instead of another thing called data ownership, which was something we followed like 30 years ago or something like that, right? There is no such thing as data ownership within microservices. You have to think in terms of facts. You can think in terms of events and other types of communications, but the rule is single point of truth. There is only one place that can state a certain fact, and that's it. That's the rule, right? And you don't have to ask somebody else for information. You can get that. The information can be duplicated. There's no problem with this because when you go into distributed system, you are limited by the speed of light, and you will not be able to provide any kind of consistency except for eventual consistency, right? Now, another change is the change in the culture, which means that, for example, if you used to have a single architect or like a group of architects or maybe the department of architecture, that's not going to fly anymore. The reason being that because the teams are going to change and develop very, very fast, they're also going to change the architecture very fast. So you need a different approach to architecture. Now, what you can't have, you can have basically an architect within every single team and those teams cooperating together. You can go into things like architecture guild, which is quite popular for managing this type of architecture. You can go into other options, but you will not have centralized architecture. That's the thing, right? Decisions will be taken and made on the fly as people develop. And that's okay. That's the point. The point is we want to develop very, very fast, and the speed is going to be really high. So we need this approach. And then we have another thing, which is infrastructure is going to be more complex, right? So then you have to have those people that will handle this infrastructure. And as you said, the cognitive load is going to, the more infrastructure there is, the more cognitive load on the developers themselves. So what companies do, they created this kind of supporting teams, which only provide tooling and basically take off the cognitive load from the other developers who provide the business features, right? So if, for example, I worked in Allegro, and when I worked in Allegro, a lot of different problems where I didn't have to think about it at all, right? Because there were teams that could provide me with software as a service or tools as a service, or basically solve the infrastructure problems for me. And if you go to the public cloud, that's the same situation. However, even within the public cloud, you will have to learn the public cloud and the services there. And it's not as simple as when you're working within an organization, when you have the team taking care of it, so they can explain everything to you. Right now you're a customer to the service provider, to that public cloud, and they usually don't care much about you, right? So they are going to do things which do not fit your setup, your problem, and you're going to have to live with this. And then the last thing I would say in terms of the big differences and the prerequisites to microservices is you will have to drop end-to-end testing. Now, that's a big thing for companies like banks, right? Because they cannot imagine any other world than doing end-to-end testing. But it's not possible to do end-to-end testing because it's not possible to have a test environment, a pre-production environment, which would resemble the production one-to-one. And the reason for it is because you have independent deployments. So if you have 50 teams working on microservices, there's going to be a deployment to production like every 10 minutes, perhaps. That happens, right? So no way to do end-to-end testing. Instead, you will have to learn consumer-driven contracts. You will have to learn test-driven development, behavior-driven development, a different approach to testing the software.
Yeah, so does it mean that in terms of testing, because this is actually a big deal, right? As you mentioned, for many different companies, especially like this critical, like the financial oriented, like what you just said is, yeah, it might sound kind of scary. So do I understand that, yeah, we need to forget about end-to-end testing, and now what you're saying implicitly is like you would rather try to do this in a Netflix way, so chaos engineering in which we'll basically test on the production, and eventually only we need to ensure that each of these microservices is well tested on its own, but whether this works as a system will eventually found out on the production?
Yes and no. Let's not involve Netflix in it, okay? Netflix is one of the companies, and they do it their own way, and it doesn't fit every other company. The thing is, you have to have every microservice tested well, and we are talking about a unit test, integration test, all that kind of stuff. However, you are not going to deploy it to a test environment to get it tested with everyone else because, well, you don't have that environment because you cannot prove that this environment will be one-to-one with production. So you will have to learn how to test the communication without a test environment, to test the communication with other microservices. And you do it using consumer-driven contracts. There are libraries for this, like Pact or Spring Cloud Contracts. There's actually a lot of different libraries for this. Pact is most likely the most popular right now. So when you do this, then you know that you're going to fail on production as you build your software locally on your laptop. You don't need to have like the test environment to be able to say, yeah, we're going to fail or we're going to be all right? So that's the second thing. And then at last, you will have to do you will have to be able to verify all this on production. So you will invest into a thing called observability, right? Where you are able to look at the system and you have those dashboards and you have those logs and you have all those things telling you that even when you have a large traffic that you can just look at the logs and be happy with this, right? But with all those metrics and all those information, you will be able to say, yeah, that works well. Let's actually, we've done the deployment and it's a rolling update. So basically, the new versions of the microservice are being deployed as the old one still works, right? So there's zero downtime deployment there. And when you're turning on the traffic to new versions of the microservices, you're going to learn how to do it so that you turn 1% of the traffic, then 50% of the traffic, and so on. So basically, you're minimizing the cost of failure, and you have to design for this. So you will have to build your architecture so that you are minimizing a possibility when things break and the impact on the customer, basically, right? So I have a lot of microservices and some of them may break and nothing happens. Like the customer won't see it, right? And so it's easy to deploy them and basically test them and not worry too much about them. And I have some of them where the SLA is very high and basically I need them to keep running, right? So there's a lot more stress deploying them. But then again, I have all those tests on the integration part. I have all those tests with the communication part, with consumer-driven contracts, with other microservices, and with the customer itself. And then I have the observability to be able to tell you, yeah, it works okay, and so on. So there's a lot of different things you have to learn there.
Yeah, actually, I must say that I'm very glad that you mentioned observability, because this is something that actually I would say that once we do the workshops once a while, people are actually surprised that we cover those topics. And once they actually saw they can see the actual, even small distributed system up and running, and suddenly something breaks, they have actually no clue what happened, and whether this was the issue on the protocol level, or maybe there was some sort of the business logic that failed. And once you actually start introducing this observability pillars, like so the logging metrics, especially the distributed tracing, then people are starting doing, okay, so now I can see how we have the microservices. That was the step number one, but now we can clearly see how this lives on the environment. And that's something that people, I would say, are not very aware of once they think about the microservices.
Yeah, I think we should actually define the term observability here a little bit, because a lot of the developers don't have experience with that. So when you can see the logs on the production, and when you know after the fact, when service breaks, what happened, that's not observability. That's monitoring, right? The monitoring will tell you, okay, something is wrong, and here are the logs. Observability is when you can watch the system before it breaks, and you can decide that it will break, and you need to do something about it, right? So what kind of metrics are those, right? So basically it's everything. It's looking at the threat pools. It's looking at the memory consumption. It's things like alarming so basically you get alarms whenever you are getting close to the limits of your system, right? But it's also logging the different situations. And so if you have no information about what happens on the system, and you cannot basically tell whether it behaves okay or it will break soon, then you don't have observability. So you have to invest into that.
Mm-hmm. So this actually boils down to this paradigm shift that you mentioned about structuring the teams. When you have your developers being aware that there is some kind of monitoring, tracing, and other stuff that they might not know from a typical monolithic applications, or maybe even from the modular monolith applications, and they need to, for example, implement some or integrate some library into their code to actually help the DevOps team to make use of these metrics, right?
Yeah, let's start with there is no such thing as a DevOps team. Okay, that's a big problem with microservices. Oh, we have developers and we have a DevOps team. No, you don't. The DevOps team means you have a team for operations, and that's not DevOps. DevOps is developers operating their system on production, right? So that's the main clue. Like, if you I know, I've been doing this for years, where I would create a system, a monolithic modular system, give it to someone to run it on production, right? And so I don't have to look at it anymore, or I don't have to watch it and think in terms of how it behaves, whether I should do something about it or not. Like, when you start operating your own system on production, everything changes. Like, your approach is going to be completely different. You're going to build for resilience. You're going to build for low cost of maintenance. You're going to design with these things in mind. You don't want to be there and debug problems in production. You want to build a system so there are no problems in production. And of course there will be, but you are going to minimize this. So you need to be able to operate this. When you have a separate DevOps team, then first of all, from the naming perspective, that makes no sense. Developers operating their system, right? And now you have a separate team for that? What kind of a bullshit is this? And a lot of companies actually think in these terms, right? So that's a problem. You can't have it. name it in any other way. Either you have operations, or maybe some companies do that. They think in terms, okay, this is the infrastructure team. Those people are keeping our Kubernetes clusters alive. They are keeping our Kafka clusters alive and databases alive, right? They don't do operations in terms of my microservices on production. I do it as a developer, right? What they do is they provide all those tools. And we lack a name for this, or basically there is a lot of names for that, but some people who do not understand DevOps actually think that this is the DevOps team. No. This is we could call it reliability engineers or operations. Actually, no. So basically, these are the tooling teams. These are the teams supporting other business teams. That's it.
Yeah, I must say that I'm very, what you said right now, and also once you were describing the microservices, actually was quite, maybe not surprising, but it's kind of funny because I've just switched the projects and I'm now involved in the one in which we have so-called DevOps team, which is exactly doing what you mentioned, because at the end of the day, they have nothing in common with the actual development. So it's more like taking care about the AKS stuff, etc. So everything regarding the infrastructure. But because of course you need this centralized point and you need the qualified engineers who will actually know what they are doing, especially if you are within. Actually, it doesn't really matter whether you're on premise and you're basically managing the cluster or your own. If you are doing this on the cloud environment, you still need a well-qualified engineers who actually know all the tricks, especially regarding the performance and the cost-wise. This needs to be someone qualified for managing this on the organization level. But yeah, this is actually quite funny that you mentioned that, and I immediately has the recalls from my company. And I wanted to just slightly come back to what you mentioned, because there were quite a lot of topics that you discussed. Why would you actually would like to have the microservices? And of course, there were few prerequisites that you need to meet in order to think about microservices in some sort of effective way. And probably this will be some sort of way of not failing eventually in the future. And you mentioned the Conway's law. And I wanted to ask a question, especially regarding to the current situation, so the COVID pandemic, because I would say that, let's be honest, I mean, the way that we work as a teams slightly, I would even say that quite dramatically changed over the last 2 years. I mean, at least here in Poland, there were tons of companies and the teams who were oriented around the offices, and they were tightly coupled in terms of communication. Everyone could see each other, discuss different things, and all of a sudden we had to change the culture and the way that we work, because now we are not only distributed in terms of the offices that we have and the places that we do our work, but we sometimes even work in a very asynchronous way, in which I might eventually start doing some sort of job. My colleague might join me a few hours later. And when I think about what you mentioned, so this big ball of mud being developed by hundreds of developers, to me it just starts being very hard. It's even harder, I would say, to think about development of such a product being a monolith if now I don't see the people. I need to communicate using some sort of Slack, Teams, or other channel, and yet still we might be in a different time zones because maybe not everyone is from Poland, and we need to deal with that. So my question is, what are your observations about the COVID, and could you elaborate more about the Conway's law? What is actually Conway's law, and how this may actually impact the way that we're doing the software, especially when we think about the microservices?
Okay, so let's start with the Conway's law. The white paper is very short. I think it has got like 7 pages, and it's got only it's really easy. You can read it sitting on the toilet. But basically, the clue is this. It doesn't matter what you design if the people who are building this have different communication groups and channels, because they will build the system so that it resembles the structure of the teams. when people are communicating a lot with each other and with ease because they have the same culture, the same time zone, or they are in the same office, in the same room, then their software is going to communicate a lot. When they have differences in terms of let's say it's harder to communicate because of different cultures, different time zones, and also because they are just in different cities, for example, or different offices, then they will try to have as little communication as possible because the communication is harder. So basically, it's all about communication channels. If you had 100 developers and all the communication channels were exactly the same, so everyone was, let's say, in the same office, or everyone was remote, and everyone was from the same culture, then you would not notice anything except, like, you would be able to develop any kind of architecture you want. However, that's not how it works in real life. That's not what you have. Usually what you have people in different cities with different cultures, with different countries. And then you have people who are in the office sometimes, or maybe people who are always online and basically work remotely, right? Then what you will find is either you have to take that into accommodation when you design the architecture of the system, or they will overwrite your design of the system, and they will build the system so that it's one-to-one with how they communicate with each other. That's it. So that might sound complex, but a simple explanation is like, if you have 4 teams and they are building a compiler, that compiler is going to have 4 phases, right? Or if you have a team in Europe, in US, and in India, what you will find is that those microservices built by those teams, right, they communicate a lot within a single continent, okay, or country, but they do not communicate too much, or they communicate much less between those teams. And the reason for it is culture, distance, time zones, and communication channels. That's it. So back to your question about the COVID impact. I don't think the COVID had any impact on how we develop microservices, or whether we go into microservices or not. And the reason for it, because when I worked in an office, right, it was exactly the same. You got people sitting in one room and people sitting in the other room. They are trying to communicate they are communicating less. So they're trying to build systems so that they don't have to communicate too much. You got people in the same country, in the same culture, but in different cities. And they are trying to communicate or build the system so it communicates as little as possible between them, right? Now, the interesting also, another thing is that you mentioned that, asynchronous work. Let's be clear about this. When you're working remotely, you can have asynchronous work where basically you do not meet with each other at all, and basically you're just sending that information, storing it in Slack, in wikis, in repositories, and basically working whenever you like. Or you can have synchronous work when, for example, I start my work at 9 a.m. I join a video call and I keep that video call on for 8 hours as I work within a team, and everyone is there, right? And when we have to split because, for example, we do pair programming, then we start another video call, like a virtual room, right? So this is the synchronous communication. So it doesn't have to be asynchronous. Whether you like the first one or the second one, it's all up to you and all up to the team. Some people, they don't like to have no connection with other people. Me, for example, I prefer to see other people, right? To talk with them as I work. I love pair programming, basically, even mob programming. So when I do this kind of things, I prefer the synchronous communication. There are whole companies which work in an asynchronous way. And open source projects, most of them are actually asynchronous due to the fact that people are not even hired by a single company, but they just volunteer their own work. So there are different ways to structure this, and it's got nothing to do with microservices. Because Conway's law is real, it applies even if you're in the same office, even if you're in the same open space, because you're sitting next to someone, you're going to have it easier to communicate with them and to build software with them than with somebody who is much further away.
Okay, so you mentioned the challenges regarding the communication, this paradigm shift when it comes to structuring the teams. Now, do you think that there is something more that actually changes in, let's say, the day of regular software engineer, developer who started working on microservices. Let's just talk about the regular developer, not some system architect who maybe just draws the rectangles and diagrams on some dashboard. So do you think there is something that actually changes? Because it sounds like we have a team of developers. They just need to know about what you mentioned, the DevOps, not the DevOps, but they need to know about all this orchestration stuff, all this tooling, different kinds of testing. They need to know about these communication challenges. But at the end of the day, it sounds like they are going to still write some kind of application that just accepts the request and maybe sends some events. Do you think that that's all, or there is something more to it?
Okay, so what's the difference between the developer working on microservices and not? Mm-hmm. I think there's a lot of differences. First of all, you have to be good at operations, and you will have to learn that. If you ignore that till now in your career, you will have to learn how to operate those systems. You will have to learn how to observe and basically monitor those systems, right? So that's a lot of knowledge. Then, if you're using some kind of a platform, let's say you're on Kubernetes because it's the most popular one, right? You will most likely have to learn what Kubernetes is and how it works. Right? So you will use kubectl, for example, and see your own pod. Look at them on production when you're deploying them, right? There are ways that can mitigate the amount of information that you need. So, for example, like continuous deployment is a simple technique, and when you're basically pushing to the master or main now, these things will get deployed to production, right? So you don't have to look at it all the time, but you have to at least set up the alarms and the dashboard so that you know when something breaks and when some numbers are going to show you that, something is going to happen next. So that's a huge thing. Like, we used to learn Linux to be able to operate our systems in production, or to be able to, just have the basic knowledge about how it works. Now we have to understand Kubernetes, for example. If you're using Kubernetes, now you have to understand the kind of a monitoring tool that you use, and you have to learn that. That's a lot of learning there, right? Now, there are other things as well. First of all, there is much more freedom, right? When you have microservices, companies are going into two directions. Either they say, okay, it's free for all. You can take any technology that you want because you are going to support it. Right? You are going to operate this, you're responsible for it, you can use whatever you like. Or companies are saying something like, okay, you know what, you can use whatever you like, but because we are hiring people and we need to know what kind of knowledge we need, and because these are the decisions about not what's cool, but about, survivability of the company. So can I find Scala people here in this country and stuff like this? Then we will choose one solution per problem. So basically one document database, one general purpose language, for example, or maybe two because of different paradigms. And you will have to use that, but there is much more freedom in terms of technology. So what that means from a perspective of a single developer is, first of all, nobody's making decisions for me. I'm usually the one, or that my team is usually the one that can decide, we're going to use Micronaut from now on. Let's try Quarkus. Or let's do reactive programming, for example. It's all up to us. And in a monolithic application, most of those decisions were already made for you as a developer, right? And now you can do whatever you like. You can change the tools from single microservice to another one, right? And there's no problem with that, as long as you can support all of them, right? So that's the important part. Then the next thing is, because you can change those technologies, you're not getting bored. That's important, because it used to be so that, developer would usually change a company every 3 years. In Warsaw, it was a year and a half. That's the average time a developer used to work for a single company.
Seriously? A year and a half?
Yep, that's the statistics I got from the HR people, actually the HR people, yeah. So a year and a half, that's not a lot, right?
Yeah.
So especially if you think that, the first 3 months is introducing the developer to the system, right? So why do people do that? They do that because they can get more money, but okay, so we can pay as well and they will stay, right? But most of the time they do it because they want something new. They want to have like some kind of a progress. They want to learn stuff, right? And when they already know the technology that you use, your business and everything, that's where they're the most productive. But then that's exactly when they say, okay, I need to learn something more. I'm ambitious, so I'm going to go and change the company. With microservices, the technical part of the change, so I'm going to change the company to learn new tools, is gone quite often. Because you can change the tools. Every single microservice, you can take something new. Or you're writing in Java. Cool. How about Kotlin next time? Or you're writing in reactive programming. How about, I don't know, maybe Project Loom is not ready yet, but how about coroutines? So let's see how that works, right? So you can learn all those things, and it's much easier to keep people within the company as long as the money is okay.
Yeah, and I would add that besides that, you also... you as a company can advertise yourself as, yeah, we're doing the microservices, and I'm not quite sure, but I still think that this is some sort of advantage when you are cloud native or fully cloud native making microservices. It brings more and more developers because they think that this does not stink.
Yeah, and that not stinking part, well, I think. So there is this sexy factor, right? So that they think, okay, this is new, but it's not new anymore, right? So they think I should learn that, and that's a good point. But another point is for people who already do microservices, they are not quite often. They don't want to go back to monolithic applications for a single reason: stress, right? So when you have a big risk of a deployment, then everything you do has got a big impact. And the architecture, no matter what kind of architecture you're going to design, there's going to be big risk of deployment because that's a feature of a monolithic application, even modular one, right? But with microservices, I'm not that stressed. I'm like, okay, I'm working today on a microservice which can go down and not work for 2 hours. Nobody will notice that because it eats the events from Kafka, basically, and it sends some events to Kafka. And this is a process which doesn't have a time limit. So basically, that means that if I make a mistake, no worries there. Those events that I take from Kafka, they are kept there. Maybe even forever, right? If you have unlimited retention, which means I can move the needle back and read them again, right? So that changes quite a lot. Like I have gray hair these days, okay? So and I'm not as stressed anymore when I do microservices, thanks to the fact that there's no big deployment event anymore, and the architecture that I provide are resilient in that if that service goes down, only one feature will go down, and it's usually well protected so it doesn't impact anyone else. And I know what the consequences of my failure are, and I can live with them because they are small.
Yeah, so I must say that this actually sounds like a very good deal for the developers, especially because, of course, there are different types of developers, let's be honest. I mean, those who are really, maybe not necessarily passionate, but they want to develop their skills in a technical way, and for them this sounds like a very good deal because you're not only like need to challenge a technical solutions to which we are trained for and educated for, but you also have this freedom of tooling and less stress. Especially the tooling also is very cool because I found out that especially at the beginning of my career that there was I was involved in quite a few projects in which the tooling was suggested. I would put it this way, right? Even
and
before,
forced, I would say.
yeah. I didn't want to say forced, yeah, but they were forced even before we got the actual requirements. So it's not like we are all taught about just choose your arsenal, choose your toolbox and the tools that you're using for the particular problem. But in that case, it was no, we are going to use the relational database because, it's obvious, right? We are going to use the relational database in every single scenario. And of course, in most scenarios, this is legit solution, but not always. So in this case, what you're saying is that we can do even further. I mean, of course, it depends on the company and how they actually, I would say, approach this. But yeah, if I can basically select carefully the database engine and maybe the language, because let's say I've got very cool tooling around the Go, and let's say we've got the engineers who are specialized in Go, we could dedicate this microservice and we could write this microservice in a different language than, let's say, other written in the Java or .NET. So to me, this sounds like a very, very fair deal. But I'm really curious, maybe from your experience, how this theoretical discussion actually looks in reality. So is it like every, let's say, single company that you entered was very open to this? Like, okay, I get your point, so let's just do big bang in terms of our tooling and in terms of our infrastructure. Let's just
definitely no. This is a long process. First of all, the first problem that we have in companies is usually the culture one. Like, we've been doing this for years. I'm talking about the monolithic systems this way, so we cannot imagine how you can do it in any other way, right? Like end-to-end testing. Like, it takes half a year for a QA to understand that end-to-end testing is gone. It's bye-bye, won't have it anymore, but we are going to try to do it. Yeah, sure, you're going to waste a lot of time, but go on, right? And after half a year, sometimes after a year, they finally realize, oh, we can't. Yeah, sure, you couldn't, because everybody knows that by now, right? So, and the same situation when it comes to freedom. But I have to mention this. The freedom comes with a cost, right? So if you can choose anything, then you have to make sure that the people who make those choices are well informed. Because there are product problems in a culture, which is like people are only thinking in terms of their own CV or their own skills, and they don't care about the project. If you have one person who thinks about leaving the company next year, what they will do is they will look at the things that they can learn and not the things that they will have to maintain, right? So this kind of an approach will have its drawbacks, right? So companies are like, you don't have to go full chaos development in terms of like everybody goes for themselves and can do whatever they like. You can have discussions about it. You can have people agreeing to stuff like, okay, so in terms of a document database, which one are we going to use? Or if you need a relational database, you don't need 3 different relational databases. They are not that much different, right? You could use just one. Which one would you like? And now let's have a talk, right? Let's have a discussion about it. Because with databases, and that's another thing, like developers think in terms of databases, oh, I'm going to store information there. That's it, right? Okay, what's the backup plan? How do you do this, right? Oh, no, the cloud provider actually does it for me. Do they? Like, are you sure you can get it back? Like with every single backup, right? The backup doesn't mean anything until you actually tested that you can bring it back, right? If you can bring back the data and it's okay and it's within the time frame that you're losing some data. So this kind of situations, you have to be very careful, and you have to be very careful also when you go into the public cloud, because the providers lie, and they lie a lot. Like, you have to learn and to read the small detail there, right? So, like, for example, let's say that you want to have the database, and this is a managed database, so who cares? The backup is there, it works, right? Have you tried to do this backup? Have you seen the SLA, or basically have you seen the agreement? Maybe the agreement says, and I'm not shitting you now, that they provide 5 nines on the machine, that the machine works, not the service itself, right? And you would be surprised to find out that, sure, the system on which the database works, right? But you cannot do anything with the database at that point because, well, there is a bug there, or there's a problem with it, and you cannot do anything, and you have no power over that. So there's like, for 1 hour, the system doesn't work at all, which works on that database. So you have to, there's a cost of freedom, and that cost of freedom is that you have to learn how to be responsible. And when you have different developers in a company, then you have to have them responsible. So now you have a problem with the culture in a company. When there is a lot of infighting within the company, there are different departments, different teams, and they do not cooperate with each other. They are working for their own goals. They have like the yearly goals, OKRs, or whatever else they have, okay? And they are trying to maximize their bonuses, and that's their goal, right? Then what will happen is they will make decisions that will screw the company over because they will not think in terms of maintaining this, and they will not think in terms of they are not responsible enough. You have to have responsible people. So how do you get responsible people, right? You get them by changing the culture so that it doesn't matter how many microservices you wrote. It matters whether the business is okay or not, right? So one of the teams actually produced a lot more microservices and a lot more features, but the other team actually kept the system alive because they were also working a little bit on Kafka, for example, and so that Kafka cluster actually they prevented the failure of the cluster for communication, right? So when you think about it, you have to make so that the money goes after people who care. And you have to do it so that, everybody feels that the rule number one is to keep the company safe, right? So to keep the system operational and basically keep the company safe in the future so that they are able to use this and not fall into some kind of a trap just because you didn't read the documentation or the contract.
Okay. So what do you think would be, let's say, the most crucial factor when it comes to distinguishing the company that has actually successfully adopted the microservices when comparing to the company who maybe tried to adopt the microservices but failed for some reason? Do you think this cultural shift is the most important factor, or maybe there is something else?
No, I think the culture shift is the most important factor because it basically blocks, if you don't have it, it blocks everything else. The people, when you pay them by a feature, they will not care about the maintenance. They will care about providing as many features as you can have. And you can take a look at, for example, Samsung, which is a company that provides a lot of stuff. When you're buying a phone from Samsung, right? There's a lot of different applications on there, and you cannot even remove them. And it used to be that the different teams and product owners, whoever that was, would get bonuses based on how many applications are on the latest phone when it's being deployed. Not whether they operate correctly, whether they are not using too many resources, whether they are even needed, right? So the cultural shift is the most important one and the hardest one for large companies. For small companies or for new companies, this is easy, right? Like you can build the culture from the ground up. But how do you change the mindset of a person who didn't care about production at all the last 20 years and now they have to, right? That's a difficult part. And it's even more difficult when you have the company which has got internal politics and the departments are fighting with each other. Sometimes it's not even possible. You have to fire a lot of people to be able to build the correct culture. So that's, I think the most important part, clue from here is that when you go into microservices, you have to expect that you are going to change everything. The culture, processes, the way you structure your teams, okay? Everything, right? If you think this is just an architecture approach, you're going to have bad time. It changes everything.
Let's be honest. I mean, not every microservice application is going to be built, let's say, on top of organization with the brand new culture, of course, and the new system being the greenfield system. Sometimes we are like in this sort of position in which we have already a developers working on some sort of monolithic application. And the question is that besides the organization, like the culture that you mentioned, does from the either developers or from the architects or the operations, do you have some sort of formula of what needs to be fulfilled to actually get into the microservices? I mean, let's say the minimum infrastructure that you would need. I mean, you mentioned a few of them, but is there any other aspect that people always usually forget when they transition from monolith to microservices? Because from my perspective now, I see that actually there are some sort of discussions in which we we still don't know that much, maybe don't know, but the people are confused about the responsibility, who's going to maintain this. The people are slightly confused about the overall communication patterns. So because you also mentioned the Kafka, but of course there are other patterns. The communication strategies between the services that you could also discuss. So is there any know-how of how to do this properly in order not to fail, or you just need to let it go and eventually try to correct some issues that might occur?
No, there's actually a lot of knowledge already there that you should learn when you're doing this kind of thing. So I move monolithic systems to microservices for living, right? So and what I would suggest for companies that want to do it, or for people who want to take the company and basically move the monolithic legacy system usually to microservices, is first of all, you need to have everyone, and I'm talking about every single team, learn the architectural patterns and basically the approach for microservices, which means eventual consistency, which means read models, which means the communication channels and the way that those things communicate, right? Which means single point of truth, no data ownership, and so on. So from my perspective, the way to do it is either give them a lot of books or give them a workshop. And that's how I work. I basically take them for a 3-day workshop, and I got a team ready for designing microservices, because during that workshop, we basically designed the system as a monolithic system, then as a REST-based microservices, or a synchronous system, and then event-based system, which means asynchronous system based on Kafka. And they can compare those 3 things, and it opens up their minds a lot. From my, at least that's the feedback that I got. And so when I work with new people within the company, like they join my team, they have to learn all of this as well. And it's not that difficult. There are books about it, right? Like if you want to go into event-driven system, there is a book about designing event-driven systems by Ben Stopford, for example, on Kafka, and it's with examples on Kafka, right? So this kind of things, they have to learn that. That's on the implementation part, right? So there's a lot of knowledge, and you have to follow that. Then there is a lot of knowledge on the culture part, management part. What do we do with the products? How do we, like, from the organizational perspective or the management perspective, how do we deal with having products? What are products really, right? So that's a different mindset, but there are also books about it. There are workshops on that, and it's not that difficult. These problems are already solved. You just don't have the experience yet. So buy that experience. Either hire the people or learn from them, and you got it, right? So once you have all of these, the last thing you have to understand is that you will have to empower people, because when you have 15 teams or 50 teams developing microservices and being able to do independent deployments, right? That also means that there will have to be empowerment, and they will have to make their own decisions. So you could build a monolithic application with 100 developers and a single architect. You cannot do it with microservices. That architect will not make the decisions for 20 teams. Those 20 teams will make the decisions as they go, and you have to learn how to do that and basically teach the people and realize that you will have to empower them and let them work and make decisions. And you have to teach them instead of telling them what to do. Teach them what are the consequences. And even when they do something which sounds like, there's a lot of the silver bullets in this job, or at least people are saying stuff like, you should never do microservices. You should never do monolithic applications. You shouldn't do, you should always do event-driven systems, and you should not have synchronous communication. That's all not correct. There are circumstances and the context where that applies. And you can have communication, the synchronous communication, and it pays off. It's much better for you in that situation. You have to be aware of that situations. Just buy it, learn it, right? The information is there. Like there's a shitload of books, and from the book's perspective, there is not a single book that will explain everything, but there's a lot of books on different aspects of it, right? And if you can read all those books, if you can't read all those books, then at least hire somebody who read them or who took part in the migration and in building microservices. If you can't do both, then at least buy yourself a workshop and basically learn. But remember, every single team will have to have that knowledge. So what I see is that companies come over to me and say, like, a single team like said, okay, you know what? Last year we had a budget for some workshops, some trainings, right? And we bought a workshop from you. Now we are coming back with all the other people in the project or in the product or in the system, right? Like, please teach everyone else. Why? Because with microservices, they are going to make the decisions for themselves, and they better be informed decisions, right? So they need that knowledge.
Now that's very good that you mentioned this knowledge part, because there's a high chance that maybe you have met during your career. There are sometimes this, let's call them individual developers who might have a different point of view, and sometimes they might introduce some kind of workarounds. Let's say, in order to fetch the data, instead of trying to properly expose the public API and so on, they would just directly maybe reuse some connection string from a different database, which actually belongs to the different microservice, just to get some data from their database because it's faster and they only need this one time for some purpose. So do you think that there is some set of rules, or maybe there is some way, some advice for, I think especially the architects who supervise the teams, to actually somehow tell all the developers to stick to these core principles, because otherwise this might turn into this distributed monolith?
Yeah, so let's start with, I have never seen a situation you described, like a developer or a team trying to reuse a connection from another team. And the reason for it is very simple. They don't know where the database is. They don't have the connection string. They don't have the password. They don't have the username. Why? Because it's kept in the vault. And the vault is, well, it belongs to the team that is using that database. So you can't touch it. So the idea about, they are going to make a shortcut and basically break the communication channels, yeah, that can happen. But it most often happens when they are trying to read a Kafka event they are not supposed to. Events, when you're using event-driven architecture, can be public, which means that they are going between different teams. They can be private for a single microservice, when the microservice sends an event to itself so that you can remember it for later, because otherwise it would have to have a database, or because it does asynchronous processing, for example. So that's basically a queue. And you can have those events when two microservices from a single team are sending to each other information, when you assume that you know all the producer and all the consumers, right? If you have another team, they can steal that event if the Kafka is not protected there, right? So that happens. That's correct. What happens is that somebody is going to call your API, and that's your private API. So basically they shouldn't be able to. And if you have the infrastructure wrong, you're not protecting against that, they could do it. But with the database, that never happens, because they don't know where your database is, and they have no access to your repository. Or at least they can have the read access, but they will have no write access, right? So do they break those architectures? They do, but those architectures are usually broken within a single team, right? And that's not so bad, because it's much easier to fix part of the architecture of the whole. You have 700 microservices. You got a single team with 15 microservices. It's easier to fix those 15 than to fix 700, right? And the communication channels there. And within a single team, people basically lack the experience and knowledge. And I'll give you an example. I was reviewing the architecture for a team that used a single database as a communication channel and a single jar as a communication, like a single jar with all the classes. They called it common, of course, between different microservices, right? And when I asked them, what's going on in there? How did you come up with that? They said, well, that pattern is actually described in the domain-driven design book by Eric Evans. It's called shared kernel, right? And we decided to use that pattern because it's a simple pattern. It's very simple if you have a single team, and why not have a distributed monolith there, right? And so these people just decided to do that. And at that point, I was like, hey, I read that book twice. Maybe I don't remember it. Let's open it up. And I opened up the page on the shared kernel, and it says, the second sentence says, this pattern is used when you have two teams that there is no way they can communicate with each other. Like, there's no cooperation whatsoever due to time zones, culture, whatever, politics, right? But the software needs to cooperate, right? And you cannot have it done on a continuous integration because it's way too complex, and basically the people do not agree with each other. They will fight with each other. So you can't even have continuous integration server for that. And also, so you have to have two teams that can't talk with each other. They're doing this within a single team when the same people on both sides, right? Makes no sense. And then the other thing is that Eric Evans, when he wrote that book, he didn't describe the best patterns or the good patterns, right? He was describing all the patterns for communication between different bounded contexts, which means also communication between different teams, right? And so he said, this is what I saw when I did that research for, I think it was 300 projects, right? And this is one of the solutions. Is it a good solution? Not really. It would be much better to fix the problem, the communication problem between those two teams. Like the problem even disappears when you have microservices because you need some kind of a contract. And you don't need to continuous integration server. You just need the contract there, right? But the people, when they don't have enough experience, they will say, yeah, I found it in the book. It's got to be good, right? It's the same story that happened with the waterfall, right? Where the original white paper for waterfall was actually describing a process that doesn't work. And everybody, like not everybody, but a lot of companies looked at this and said, yeah, let's use that process. It's in the book. It's got to be good, right? No, that's the one that doesn't work, right? So that's the funny part. So I see the distributed monolith is so bad that not too many people actually go in that direction. But they can have those workarounds. And to protect against those workarounds, education is the best bet. There is stuff that can protect you and help you a little bit. So you got consumer-driven contracts like Pact or consumer Spring Cloud contracts, libraries like this. There is on the Java world, there is this thing called ArcUnit, which is protecting your architecture within a single application, modular application, right? But the best bet is actually education. And educating new people is the most important part, which is why I do it.
So to sum up, it's, if you have the situation in which you have, let's say, the developers who are not very convinced into going to the microservices, they have very different opinion. And that there might be a situation in which you simply cannot teach them anything more because they don't want to. And I would say that this is unfortunately quite common, that people just have their opinion, they try to use, let's say, the age factor as some sort of to excuse the, or maybe adjust their experience. So if there's something like this happens for the sake of our culture and eventually going into distributed monolith, microservices, you mentioned this distributed monolith. So we should simply say, okay, we are very glad for what you've done so far, but you need to go because you don't fit.
No, stop it right there. Not exactly, right? Let's talk about this a little bit. Think about it this way. When you're changing the architecture of an existing system, it's usually a large system. It's not a single team, right? Yeah. Because if you have a single team, it makes no sense. When you have several teams, then it makes sense. Or it might make sense when you want to protect against provide the different non-functional requirements. It's much easier when you can build several applications for those, which have different users and different quality requirements. But that's another story. Usually what you have is several teams working on a single application, and there is a problem with that because the reason to move into microservices is there is a problem with the old monolithic system, and the problem is usually development of new stuff is very hard and it takes a long time, right? Now, here's the thing. There will be people in development, in terms of developers, I have not met a single person that would say we shouldn't do microservices because, I don't know, for any reason. When they have this problem, they cannot develop new features. They know their time is basically they have limited time in the company, right? Because before the company goes down or something like that. So what you can do is you can say, okay, let's create those products, basically design the products, design those microservices, but then you give every single team working on their own microservices. Remember, a single microservice, only a single team has access to that repository, right? That's the rule. When you have this, you let them do the rest of the job as they please. So for example, you got 5 people that are very good at working with monolithic application, and they are scared shitless about the microservices, right? They are not good in distributed systems. Let them build a monolithic system in their product instead of building several microservices there, right? Why? Because that's a single team. Within a single team, it's not that hard to build a monolithic system. It's actually easier, right? Now, it's going to be harder to provide, like you said, being able to scale different modules, or maybe there'll be a risk of deployment. But this is just 5 people, right? The risk of the deployment is larger in monolithic application than in microservices. But when you have only 5 people, they can still deal with that. We know how to do it. So you just let them do it, right? You don't have to get rid of anyone. Who do you need to get rid of? The people that are afraid of any changes and will need to make those changes. That's usually the managers, right? Okay. They are like, yeah, but I cannot even comprehend how it works and how the culture should work, and I can't let you make decisions, right? These people have to go, okay? Because they will have to make those decisions. In terms of developers, I think I can reuse every single developer from a monolithic application except for the toxic ones. The toxic people should go, but they should go always, no matter what kind of architecture we build, right?
Yeah. And that's actually good that you're saying this, because I wanted to make it clear that maybe it's not necessarily that if you're a manager who's listening to that podcast, like, okay, so if you're not ready for the transition, I'll just kick you off.
You can buy experience, but you cannot buy the mindset. Yeah, exactly. Right? You cannot buy not being afraid. You can buy the skill sets. You can let people go, and you. But the changes in the culture, usually it's your mind that's the problem when we are talking about the management and microservices and the organizational part. It's your mind that's the problem, not that it's not a technical problem. It's not a structure problem. It's not possible to do here, right? This kind of things. I have heard from people in especially banks stuff like, this is not possible. You cannot do it here. When I hear something like this is not possible, I usually give them examples. I say, these companies work this way for years, and I've been doing this for 7 years. So how can you tell me this is not possible? This is a proof that it works. And they say, oh, this is not possible here. And usually what happens is that this is not possible here because I am afraid and I will stop you from doing this. So if I need to make that change, sorry, but you will have to go. Okay?
But I do remember that on the other hand, I think in Darek during one of the workshops, we met some teams who are actually transitioning into microservices because their manager told them to do so. Because, for example, that person will go to some conference and hear about the microservices being a silver bullet, or the person would have some friend in one of the cloud service providers, and they would make a good deal. So now please do microservices, right? That's what you want to do. So
in Poland, there is this saying, you do not talk with pigs about the stars. And the clue of it is, if you're not technical, don't make technical decisions. Okay? There used to be a concept of an ivory tower architect that does not do any development anymore, right? Don't do programming. That's bullshit. There are no people like that anymore. Or in some companies, they think that they are such people. But for working, whenever we are talking about successful companies, that's not what's happening. People who make decisions about architecture are the people who actually can implement those decisions. Okay? Can implement all of that. So what happens when you have architects that can't, that they don't want to work with code anymore, right? they can be very useful, but these are enterprise architects. They organize the architecture of the organization, for example, so that it allows for microservices and independent teams. These are the people who are negotiating, buying, for example, some third-party tool and the SLA for that tool. They are investigating the protocols that that tool uses, right? And how to integrate this, right? They don't have to, they are very useful, but they do not design the system, the architecture, and they have nothing to say about the technical part of that system. So if you are a manager and you used to be a developer, this is okay for a few months, maybe even a few years. You will still be more or less up to date, right? Because you remember how you did that stuff. But if you think that you can do this kind of a job and basically make technical decisions based on presentations, sorry, that won't work that well.
Yeah, that was exactly this case, as far as I remember. I mean, that was even some sort of the partnership with this specific provider for the cloud or something. And yeah, so the decision was just coming to the developers all of a sudden. It was like, what?
But I do understand why some managers do it. And the reason is, let's say that you have, like say, 5 teams, and they are not very experienced. They are not experienced at all with microservices. And you notice that we lose a lot of time because we have to synchronize, because we have, there is a big risk of deployment, and our customers are basically suffering, right? So we fail our customers, we fail our business, and you're trying to fix the situation. And you're looking at the situation and you see that, well, we have non-modular monolithic system that's very hard to implement and basically takes a lot of time to implement anything and to make any changes. And maybe there's everything done in stored procedures on a database. It's a shared database. So you're all screwed because you cannot use any technique that is up to date. So it's not going to be efficient, right? And they want to change that. And when the push doesn't come from the bottom, then it has got to come from the top. So I do understand that there are situations when the CTO or some kind of a manager would make that decision and push everyone and say, okay, either you learn this or we are done. Remember what Jeff Bezos did with Amazon, right? He wrote that email saying, from now on, if you try to use any kind of API except for the formal API, for the API which can be used from external companies, so you have to treat your service as a product, and you have to treat your service, you have to do rate limiting maybe, you have to, open up your API, and if you try to override that and go in any other way for the data or that service, you are fired. And it works. It worked, right? So that may sound like a toxic management, but sometimes the situation is so bad that you have to push the people, right? And some of them you will lose, of course. But if I may suggest something, when you can hire somebody who will push from the bottom, and then if you want to, you can still push from the top. And when you have those two pushes from the bottom and from the top, that's an easy success, right? When it's very difficult to hire people in terms of with experience on microservices, they cost a lot. So you can get some temporary help by hiring consultants, or maybe send at least your people to the workshops, right? Don't buy them workshops, send them to those workshops, right? Make them watch those videos or go and talk with the people, right? So make sure that that happens, and then push from the top. If you just push from the top and you do not care, like you do not help people learn how to mitigate the risk and basically how to work with this, and the only pattern that actually works for going from a monolithic system to microservices, then that's going to be a problem, especially when you want to go into microservices within a single team. Like if you have a single team, why would you even go into microservices?
Yeah, exactly.
Like you would have, there are some reasons, there are some good reasons. Let's say that you have two types of customers. One of them requires a very high SLA, and the other one, it requires a lot of new features. And you got the situation when if you build a single application, what you have a high frequency of change and a high SLA. That's a very difficult thing to do. High SLA and high frequency of change. Just because, guess who's introducing bugs to the system? Developers. So when you're changing something, you're introducing bugs, you're breaking the SLA, right? Now, if you split that into two different applications, that's easy, because now you might have a single application which needs a high SLA but has got no changes whatsoever. That's easy. And then you have another one which has a lot of different changes but doesn't have a high SLA. So that's much easier to do. So you can have that this is not microservices, that just two applications. This is a slightly distributed system, but it's much easier to do than going to 15 microservices for a single team. And basically, microservices are when you're going there with more than one team, I would say, except for the situation. Maybe that's always true, okay? Mm-hmm. Don't build microservices when you only have one team, unless the whole organization has got like the whole infrastructure there, and you all know the stuff that you're doing, right? So it doesn't really matter, because, well, we're building a new product within a company that already uses microservices. For example, Allegro, right? And when they have already 1,500 microservices, how difficult it is, you think, to create a new one? I'll tell you, it's dead easy. It's much easier than to change anything in existing microservice, right? How long does it take for me to create a new microservice using a tailored service template that I wrote? Sam Newman actually describes that pattern, right? 4.5 seconds, okay? To have pipeline, to have code base, to have everything. So if you can create a new microservice in 4.5 seconds, then it's not that hard. Of course, that's a little bit oversimplification, because I didn't automate the dashboard for monitoring, unfortunately, due to the Azure limitations. But that's a completely different story.
Okay. Yeah, but I'm glad that you also mentioned those, let's say, non-functional requirements like the mentioned SLA and splitting the microservices, because speaking about defining the boundaries of the microservices, I mean, people always, I mean, not always, but they often, when you see different types of materials, it's like the boundary of the microservice, of course, needs to be defined somehow. And of course, you can try different heuristics for this. Of course, the first being like building around some sort of noun, or maybe like.
Oh no! Don't do that.
Yeah. I mean, but this is like, okay. To me, like, I do the e-commerce, so there probably will be the customer, like the shopping cart or something. So, of course, later when you are more, let's say, I would say conscious and you're aware about the, let's say, the whole domain-driven design, especially the strategic part, and you know that you should more focus about the behavior that you actually have within your system and all the signals. Then you start thinking about this in a slightly different way. But I guess what you also said is that it's not always like, even if I distill the subdomains, put it into bounded context, it's not always one-to-one mapping between, let's say, the context and the microservice, right?
Definitely. The rules are here. First of all, to be able to design microservices, I think you need to understand modules. Okay? The reason being, when you have a module, and it's a difficult thing for new people to understand, right? The thing is, you will learn that modules are responsible for processes, not for data. Okay? And then when you do that, then you will see that a properly configured module or built module is a candidate for a microservice. And then those microservices that you're going to have are also not going to be responsible for a noun, for data, but instead for a process. So the example I always give is the simple one that everyone understands. You can have a user microservice, right? Mm-hmm. Or module. And you would say like, okay, that user, so what does it do? Well, when you want to log into application, that's the service you call. If you want to get the authorize, basically, so see if that action is possible, that's the service you will go. If you want to register a new user to application, that's the service you will go, right? Now, that's completely incorrect. And instead, you should think in terms of processes. So you will, if you are building a modular application, you will have three modules. You will have the registration module, the login module, or authentication module, and you will have the authorization module, for example. And they are going to talk with each other, because otherwise, the login module the authentication module doesn't know about the new user who just registered, right? Now, when you go into microservices, the microservices are how you deploy those applications and how you those modules and how you manage them. So basically, as long as it's all built by one team, you can have those 3 modules in a single microservice, which you could call user microservice at that point, right? So if when you have those 3 modules, that would be okay. But when you look at the real microservices, that's not what's happening, right? You will find out that, first of all, from a technical perspective, the approach for logging and authorization is completely different in microservices. So you will have the JW2, you will have the stuff that, you can basically, you don't have to ask and talk with anyone, and you can verify the request from the user and stuff like this. But the more important thing is that you will, like, when I teach those 3 approaches, I think that works the best because people learn that, if I had those 2 modules in a single microservice, then I would save a lot of communication in terms of the CPU on serialization, deserialization, and connection. And I would save a lot of throughput, okay? Because I need to send 1,000 messages per second here, right? And if it's done within, for example, a single virtual machine, like the JVM, for example, that's easy. No problem with that. If it's done over Kafka, okay, that's not a difficult thing to do, but the problem is you're going to pay the price for serialization, deserialization of that. If you're going to do it over REST, then you have to start a new connection every now and then, right? So that's even worse. And so people, when you are aware of this type of, the cost of a communication versus the rules of microservices, like we want to deploy this independently, then there is only a single team that handles the code base of a single microservice, never anything more, right, than that. Then you can make those decisions about, from a technical perspective, like I'm going to join those 2 modules that are in different bounded contexts into a single microservice for a very single for a technical reason. I would suggest usually that a microservice should be within a single bounded context, but a bounded context can have a lot of different microservices. But we can break that rule when it makes sense from a technical perspective, because microservices are very technical. They are about how we deploy the stuff and how it communicates with each other. And there are so many reasons, technical reasons, where you would like to have in-process communication instead of Kafka and a message, or the other way around. That you have to be aware of all of that. So I cannot explain more during this meeting. I need 3 days to show you and basically be able to teach the people. You have to understand this. You have to create new connections in your brain, basically, and you have to basically try to do it. What we do during the workshops is design the same system as a modular monolithic application and microservices and event-driven system based on Kafka. And when you do these 3 things, so that's also microservices, but with asynchronous communication, when you do these 3 things, then it opens up your mind and you can make those important decisions, and not just based on some, the microservice should be like a bounded context. Okay. I did event storming, and in event storming we had those 3 boxes. So aggregates. So let's focus on those aggregates and put them in different microservices. No, don't do that. This is just completely wrong.
Okay. So on one part of the equation, we had what you just described. Let's say this more soft strategic part to actually find out the proper boundaries, modules, subdomains, bounded contexts, and finally the microservices, which I do believe is even more important than maybe the technical aspects, which are of course important. But if you get your boundaries right, you are, let's say, most likely going to get a distributed monolith at some point. But on the other hand, on the other part of the equation, we have, let's say, a lot of buzzwords, a lot of this, quote, so-called great tools. And I think especially for the developer, the software engineers who are usually more technically oriented people, they might not find this strategic part too interesting. So we have a bunch of these great tools. And when you look at, for example, this cloud native computing foundation landscape, there is literally hundreds of different libraries, tools, frameworks around different areas. So do you think we actually need this stuff? Do they really help us? Or there is just like, I think there's even more stuff than there was back then in related to JavaScript frameworks. And isn't all this stuff somehow just kind of unnecessary crap that adds more complexity than the actual value?
Well, look, tools are like androids, right? They are a benefit or a hazard, and it's all up to you how you use that, right? Okay. The situation, I'll give you an example of the situation when developers came over to me and said, we have this single team and we are doing the distributed system and we're trying microservices. When should we actually implement the service mesh? And I said, why would you do it? Well, we heard that this is good and it improves the security and it improves. Yeah, okay, this is all okay. What's the trade-off? What's the cost for that? What do you mean the cost? Well, when you go into that and you say deploy the Envoy proxy there everywhere, right? And you're gonna use that. What will be the cost for you? And they come up with, we will have to maintain it. Exactly. So if you are a single team and you want to maintain it, cool. How long is it going to take out of your sprint? How much time is it going to take? And they say, yeah, that could be a lot of time. We actually have to do a PhD on that because we know nothing about it, right? You have to learn it. You have to make mistakes. You have to reconfigure this. Okay, so maybe if you have only 5 people and you need to deliver business value, maybe that's not the best idea, right? Now, on the other hand, when you have 500 people and you would like to improve the security, for example, or the communication, basically channels of all those microservices for 500 people, which most likely will be 500 microservices sooner or later, then let's spend a single team full year implementing the service mesh and basically configuring this and taking this as a service, right? And sure, that makes sense. So all those tools are solving a problem, right? If you're trying to come up with, I'm going to use a tool and then I'm going to find a problem for it, then you are in a Bitcoin area, right? That makes no sense. If you have a problem and you want to find a tool to solve that, that's a good way to do it. Now, it is important to be aware what kind of problems you have. And people sometimes don't know there is a tool that can help them, right? So I would say it is important to learn about new stuff. So go to conferences, listen to people, show how they, present those tools. Just don't listen to marketing people, right? They're always liars. But listen to developers that use those tools and make decision based on that, whether this will improve the time for integration tests. I can use test containers, for example, so I don't have to install Oracle to be able to test my system. That's beautiful. That's a no-brainer. You should do that, right? But there are also tools that are completely wrong or too complex for your situation.
I really like this approach that we should actually focus on the business value, and I'm really glad that this term actually was mentioned, because I do believe, and I think that we as a developers sometimes, because the technical part is just one, I would say, thing, but at the end of the day, does business really care about what tools, frameworks we are using? I mean, after all, they want to make money, and we are paid using the money that they make on top of the business processes. So yeah, I would say that it's a good that you mentioned that, and of course this depends on the size of the company and
I think it's important to say one thing. Look, everybody is trying to show you that they have big balls and they have a lot of knowledge and they're using Kubernetes right now, right?
Yeah.
This platform actually took over everyone, right? Killed everything else out there that was present. So all the competitors are basically dead, and you have to understand Kubernetes. That's not true. If you have 5 people, don't go into Kubernetes. You don't need to go into Kubernetes. If you have 20 people, can you actually develop the microservices? Yes, you can. There are simpler solutions depending on your platform, on the technology that you use. Go into Azure, for example, Microsoft Azure, and look at the managed I don't remember, they call it something Fabric, I think. Service Fabric or something like that, right?
Fabric, yeah.
Look at what they offer, right? And maybe it's going to be much easier than to learn Kubernetes and to operate the clusters of Kubernetes. If you don't have too many people, take a look at the other options that you have, right? Don't go into the most complex solution. When you have tens and hundreds of developers, then it's much better to right away learn from the best and basically follow them sometimes. So basically, let's take a look at the tools for communication. What kind of an event bus can we use, right? And you will sooner or later learn that most of the companies use Apache Kafka. And the alternative to that would be Apache Pulsar, for example, but not the whatever kind of event bus the Microsoft has. Okay? And there are good reasons for that. And now you have to understand that and decide whether you would like to buy that as a managed service from Confluent, which will be 10,000 euros at least a month, right? Mm-hmm. Or whether you want to host it yourself and basically learn to configure this because you got cheap developers from Poland. So basically it's going to cost much less. Seriously, like if you look at the prices there, I was looking at the offering from the software providers, and like my manager was like, "Oh, that's a lot of money." No, that's a lot of money because you're paying shitty money to your developers. If you had to hire one guy from Silicon Valley, from San Francisco, that would be like, this is less than what he earns a month, and this is a managed service, which means, it's very difficult to hire new people right now. So you might not even have a choice. You might not have the people to be able to learn this and use that. And so the managed service scales with the cost. Okay, so the cost is higher, but maybe that will make sense.
Yeah, especially I'm curious what's the cost of the, let's say, the developers and well-qualified engineers working on the, let's say, like the microservices, comparing to this rescue mission in which you basically need to dive into this mess and try to, like you mentioned, these jar files being exchanged all across the teams. And I guess that the price for that mission and the cost overall for the company would be significantly higher rather than having the qualified engineers.
Well, yeah, but most of the software doesn't need to be great. Okay. Yeah. Most of the software, like when I talk with developers and the companies about their non-functional requirements, and I talk about them about the SLA, for example, right? So how many nines do you need? And they say, we didn't even discuss this with a customer. What kind of a performance do you need? Well, it would be cool to have a few thousand requests per second. No. What's the number exactly, right? And who asked for that? And they say, we didn't talk with the customer. Most of the software actually has got those requirements. You have to not piss off your customers. That's it. If you're fast enough so they don't notice, that's okay. If you're stable enough so they are not pissed off by your software being down, it's okay. And that's it. And it's not difficult to do. It's not difficult to do when you realize that the CPU of this machine has got 5 gigahertz, right? So to do something too slow is actually either you have a huge traffic, or most likely you're doing something stupid, like for example doing a select from a database without hitting indexes, right? So that's a full table scan, and that's dead slow. Or maybe you didn't actually think about the thread pools, and so you have a thread pool which is saturated here, and so the Tomcat thread pool is basically dead because it's all waiting for, and then the customers are waiting as well, right? So our mistakes are making the software work bad, basically, usually. Now, there are of course cases where you have tens of hundreds of thousands requests per second of transactions, and then you have to be fast. Sure. But for most of the developers, like, what's your traffic? Come on, give me the SLA. Because of what? Like, what's the impact on the customer of this service being down, right? And you find out that the only thing they can, like, you can implement the shared kernel and be okay with this in terms of the performance and stability of the system. Everything will be fine. Actually, it will even help you because databases are, well known and kind of stable. The problem with shared kernel will be that it impacts your development. So you're slowing down due to that. There is more mess. That's the problem. But from the perspective of your customers, apart from not getting new features, it will be fine.
I have actually one last question before we finish this episode. So you've been working microservices for many years now. And let's say, what are your predictions or maybe some observations about this approach in general for, let's say, for the next few years? Do you think, is this still going to be let's call this a thing, or do you think we are going to come full cycle once again, and then maybe some companies who failed with microservices will get back to working with monoliths for years, and then they will start learning about microservices from the scratch, or there will be something totally different? What are your, let's say, predictions?
Okay, so considering that Fred Brooks 40 years ago found out that you cannot build a large system with a lot of different developers working on the same code base, I would say it's pretty safe to assume that distributed systems are here to stay. Okay? Now, it doesn't mean that the monolithic applications will disappear, because there is still point to make in making them. Like, you only have a single team to do that, or you have no infrastructure for anything else, and you would have to provide the infrastructure yourself, or other reasons for that, right? So these are all viable options. The options which make no sense is a non-modular monolith, for example, or distributed monolith. That makes no sense. That's the job done wrong, right? And there are other options as well. Like, we found out the serverless programming, right? And that's another viable option, but you have to understand the trade-offs. Because if you, like, I've seen, I have seen managers and even enterprise architects, the people who do not code, right? Go into, like, get very excited with serverless, right? Now, when you go to them and ask them, okay, so, that's all cool. So how do we do integration tests with that? When you go to them and say, okay, so how are you going to review the code when you have this is implemented by a single person? It's very easy, right? So how do you organize the teams, and how do you basically protect, like, what's the pattern for testing this? And you find out that this is just happy-go-lucky kind of thing, right? You have to be professional when you do serverless, just as you have to be when you do microservices, right? And you cannot just say, yeah, this is much simpler because I don't have to think about anything else. That's incorrect. So going back to where it's all going to move to in the next few years, no idea. But distributed systems were already there and they're going to stay. And the only thing I think is, like, the changes that we are going to see is that more and more systems are going to public clouds, and I hope there will be more public clouds than what we have right now. Okay, and the alternatives to all of that. And I think it's gonna get much easier to create microservices because of the tooling, which covers the all the pains and the problem with the cognitive load on the developers. Like, everybody who's using Kubernetes says, well, it might be a little bit too complex for a normal developer. I don't exactly agree with that, but I understand the pain, and I understand the tools that the companies like VMware are selling so that it's easier, right? Like, let me actually prepare all of that for you, because, my pipelines and your pipelines, they're not that different if you think about it, right? We need to go to the vault and get the secrets there. We need to deploy, to run the build. We need to deploy this somewhere, right? And you will find out that the tooling that is going to get there is going to be much easier. We can also observe that it's going to get more mature, because like the SNCC, for example, the tooling for checking your different layers of Docker images and vulnerabilities in there, right? That's an important thing. That's a very important thing. It's great that it's there and it does it automatically and you can put it into your pipeline. That's a great thing, right? So think about how many things we have not found out yet. That's great. But microservices are going to here to stay, and it's going to get easier. That's what I think.
And hopefully this will actually this will be a thing. And to me, it's just incredible. That was incredible to talk to you, because what was very special to me was that you had quite a few opinions which were maybe not the counterintuitive, but were quite opposite to what you might found out there regarding different topics. So you can already see that those gray hairs that you mentioned actually came from the experience. So what I could say is, of course, we would like to thank you so much for your engagement and for being us today. Of course, the whole all the things that you mentioned, we'll do our best to put into the description and into the links, so all the resources will be out there. And what can I say? Just thank you once again for being here with us.
Thank you for having me. See you next time.
Thank you. See you.